All right, lesson 2, circles, chords, diameters, and their relationships. And we're going to start not with the open-end exercise, but with problem number 2, where they ask us to construct a circle of any radius and identify the center as point P. And then they ask us to draw a chord. I'm going to use desmos.com/geometry to do this. So I'm going to let you go ahead and see what I'm doing. I'm simply going to create a circle. I'm going to put in a chord. They asked me to label this. Okay, then next they're asking us to construct a perpendicular bisector of AB. So let's go back. And if I select more tools, perpendicular line, and we want to choose a, let's see, a line and a point that it's going through. And they're asking us, what do we notice? And this is kind of an interesting one. So let's draw this a little bit and see if I can make sense of this here. Do you notice anything here about this angle? Does that look like a 90-degree angle? Do you notice anything about this length right here? It appears that that perpendicular line also bisected that. I'm going to throw in a couple other things here. Notice this radius and this radius are also identical. So we have an isosceles triangle. We got all kinds of great information here. They asked us to keep going about this, and we kind of already did what they've asked us to do in terms of just understand that we're going to be dealing with right triangles and bisected chords. This is a chord coming across here. All right, so from that, need to answer some questions. They said if the diameter of a circle bisects a chord, then it must be perpendicular to the chord. And they said if we're given this, then over here, then this is a right angle. Down here, if the diameter of a circle is perpendicular, so if this is true, right, then over here, what has to be true? Well, we know that these two have to be congruent. If two chords are congruent, in other words, this chord here and this chord here are congruent, then over here, what do we know about the distance to those chords? We know that those are also congruent. If the center of the circle is equal distance to the two chords, so if they're saying if these are equal, then these chords here have to be equal, right, from there to there. These are our conclusions that we're drawing from these. We're going to keep going with this. One of the things we know that all radii of a circle are congruent, right? And they said if two chords are congruent here and here, then their central angles are the same. So they're talking about here and here. Now we defined central angles in the first lesson. We also know that these are all equal. Those are all radii. Okay, and that was supposed to go from here to here. We know that. Next one says if two chords define central angles as equal. If these say these are equal, then we now know that these chords here are equal.